Hey guys, a very warm welcome to the session. I hope you all are keeping super well and are in the best of your spirits for today's session. Now, in today's session, what we are going to do is something very interesting, something favorite of the JEE team, as well as very relatable. Now, what is that topic? The topic is to find the rank of a word in a dictionary. Now, this word that would be given to you, whose rank you would be asked to compute, can be any word. It can be your name, it can be my name, it can be any of the loved one's name, or it can be just any random word that you want to find the rank of. But the drill is, what do I mean by the term rank of a word in a dictionary? Now, what happens is, suppose I give you a word. Obviously, a word would be always given to you, and you would be asked to compute its rank. Now, that word can be a very small word, or it can be a large word. Depending upon the complexity of the word, there is a way to find the rank. What is that way to find the rank? Let us begin understanding how to get the rank of a word in a dictionary. Now, if I give you the word cat, now this word is made up with finitely many letters, which is 3. It's made up with the letter C, with the letter A, and with the letter T. But with these 3 letters, not just the word cat is made, but in fact, many more words can be made with the same 3 letters. The task is to find out all the words which can be made by all the 3 letters of the word cat. Cat is definitely one of the words which can be made by all the 3 letters of the word cat, obviously. But apart from cat, what are all the several rest of the words which can be made from these 3 distinct letters? That we have to first of all collect. So let's begin. You know that ACT, ATC, CAT, TAC, CTA and TCA. These are the 6 words which can be made by all the letters of the word cat, right? And you can see cat is definitely one of them. Now, what you do is, the moment you have collected all the words which can be made by all the letters of the given word, which in this case is cat, you don't just stop there. What you do is, you arrange all these words in dictionary order. Suppose you were given this task of forming a dictionary with these 6 words. Now, you would have all visited the dictionary. In the dictionary, there is a pattern in which the words are arranged and they are sitting. The very first letter of every word is in alphabetical order. Then the second letter is again in alphabetical order. The third is again in alphabetical order, and using this drill only, every time you find any word in a dictionary by flipping the pages and then falling to the right word. Exactly in the similar manner, if I want to arrange all these 6 words in dictionary order, how would I be arranging them? There would be a first word, a second word, a third, a fourth, a fifth and a sixth. Each word will be given a certain position in the dictionary, a certain order in the dictionary, a certain rank in the dictionary. Yes, the position in which each word would be coming in the dictionary, depending upon the dictionary order, is going to mean its rank. So let's begin jotting the words down. The very first word which is going to come in my dictionary of 6 words, which are all made up with all the letters of the word cat, would be which word? Obviously, it would be words starting with A, right? Because A in alphabetical order comes as the first letter. First word would be ACT or ATC. Now, that is going to be governed by the second letter's alphabetical order. C obviously comes before T, so ACT happens to be the first word, ATC happens to be the second word. Once these are exhausted, let's focus on the rest of the words. According to the alphabetical order, which would be coming as the third word, you can see beginning from C are 2 words, and they are now going to land inside my dictionary listing. So obviously CAT would come first, or CTA. Again, it would be governed by the second letter. A comes before T, so definitely you have CAT and fourth is CTA. And once these are as well exhausted, you have TAC and TCA left. they would be coming as the fifth and sixth word. Which would be the fifth and which would be the sixth? It would again be governed by the second letter's positioning in the alphabetical order. A comes before C, so obviously fifth word is TAC and sixth word is TCA. That is my dictionary. The placing of these 6 words is, this is the first, this is the second, the third, the fourth, the fifth and the sixth. So where is the word cat sitting? Cat is sitting straight at the third position in my dictionary of 6 words made up with all the letters of the word cat. And therefore, what is the rank of cat? It is 3. That's how you compute the rank. Isn't it an easy concept? So what is the drill? The drill is you would be given a word. From all the letters of that given word, you would be forming all the possible words. That would be a large collection, right? Not always it would be as small a collection like 6 or 5 words. It may be a very large collection depending upon how many letters are there which are forming the very given word. Once you have formed all the several words made from all the letters of the given word, you arrange those so many words in the dictionary order. When you are finished arranging them in dictionary order, you find out that your given word is lying at which position, and that position is called that word's rank. Now the question is something that's going to pop up right now in your brains, that okay, if suppose I have a word which has more than 3 letters with which it is made up of, suppose it has 6 letters, then how many words can be made with the consumption of all those 6 letters? There are so many words. We cannot just keep on jotting down all the words and arranging them in dictionary order. That is going to just consume a lot of our time. So what is that strategy which is adopted to find out the rank of a given word in a dictionary when the words which can be formed by all the letters of the given word are huge? Let's begin understanding this through an example. My task is to find the rank of the word sort of. As you can see, this word is made up of 6 distinct letters, right? This word is made up of 6 distinct letters. Once I have determined those 6 distinct letters, an S, an O, a U, an R, an A and a V. These 6 letters are there which are making the word sort of. How many words can you make by consuming all the letters of the word sort of? What did I say? Number of words which can be formed, number of words which can be formed by using all the letters of the word sort of. Like in this case, 6 words were formed by using all the letters of the word cat. How many words can be formed by using all the letters of the word sort of? Now just try to understand the drill in here. When I am saying how many words can be formed by the consumption of all the letters of the word sort of, what is it that I am indirectly trying to say? I am trying to say that suppose I give you 6 places and I give you 6 distinct objects. You have S, a O, a U, an R, an A and a V. So you have these 6 distinct objects which you wish to arrange in these 6 places in all the possible ways. In how many distinct ways can you arrange these 6 distinct letters in these 6 distinct places? Isn't that enough to give me the answer of this statement? Yes, because each arrangement of these 6 letters of the word sort of in these 6 places is going to give me one word which is made up with all the letters of the word sort of, and I want all the words. So each and every arrangement is going to give me a word, and therefore how many arrangements can be there of these 6 distinct letters in these 6 distinct places? They can be 6 factorial arrangements, and therefore 6 factorial words can be formed from all the letters of the word sort of. Now you know 6 factorial is 720, which is a huge number. There are 720 words with us, all made up with all the letters of the word sort of. I cannot just begin jotting down all the 720 letters or 720 words made up with all the letters of the word sort of and then begin my hunt of searching the word sort of as being placed at which position. That is something very tedious, very time consuming and not at all logical. So what is the logical approach which we abide by to find at which position sort of is sitting in these 720 words? Now there is a first word, there is a 720th word, and my dictionary is a thick dictionary made up with 720 words, all made up with all the letters of the word sort of. Now sort of is sitting at which position? 300th position, 405th position, 700th position, 602nd position, which position? Let's find that out by abiding by a very logical approach. Okay, when you begin opening the dictionary which is made up with the words made up with all the letters of the word sort of, obviously the entire dictionary will be divided into 6 sections. The first section will consist of words made up with all the letters of the word sort of beginning with letter A, because A out of all these 6 letters comes first in the alphabetical order. After this there will be next section in the dictionary which is going to be the section of all the words made up with all the letters of the word sort of beginning with the letter O, because after A comes O in the alphabetical order. After that you are going to have another section of words made up with all the letters of the word sort of beginning with the letter R. After that you are going to have the section of words beginning with the letter S. After that you will have section of words beginning with the letter U, and after that you will have section of words beginning with the letter V. Fine. Somewhere in this section sort of is lying because sort of starts with S. So let's begin from here and then proceed ahead to actually find out where sort of is sitting, at what position sort of is sitting. Okay, so the first task, how many words are there which are beginning with the letter A? I am talking about how many words are there which are made up with all the letters of the word sort of beginning with A, because they are going to comprise the very first section of my dictionary. So I need to see how many members are there in my dictionary which are nothing but words beginning with letter A, because sort of is not going to sit over there, right? So basically what I am trying to see is, if first letter is fixed as A, how many words can be formed by consuming all the letters of the word sort of. Now sort of is made up with 6 letters. A is being fixed at the first position. You are left with 5 more blank spaces to be filled with 5 distinct letters O, R, S, U, V. In how many ways can you fill these 5 distinct letters in these 5 distinct places? Answer is obvious, in 5 factorial ways. Isn't it? 5 factorial is 120. That means what? That means from 1 to 120 will be words made up with all the letters of the word sort of but beginning with letter A. So first word will be a word made up with all the letters of the word sort of with first letter as A, and 120th word would be the last such word. 121 onwards, 121st onwards, there will be no word made with all the letters of the word sort of beginning with A. From 121 onwards, there will be words made up with all the letters of the word sort of beginning with the next letter O. How many are those words? Now let's find out. Words beginning with an O. Now when words are beginning with O, your first letter is fixed as O. Still you are left with 5 letters to be filled in 5 distinct places, because you want to make words out of consuming all the letters of the word sort of. O you have already consumed, 5 distinct letters are left with you, 5 distinct places are left with you. 5 factorial is the number of ways of arranging these 5 distinct letters, which is A, R, S, U, V in these 5 distinct places, which is again 120. So there are 120. After 120 words are exhausted, starting with letter A, there will be 120 more words next from 121 onwards to 240. there will be words starting with O. Saurav is not lying from 1 to 120. Saurav is not lying from 121 to 240, definitely, because Saurav does not start with A, does not start with O. So rank of Saurav is definitely beyond 240. It is 241 onwards. This much we have understood, that Saurav's rank is not from 1 to 240. After understanding that, okay, there are 120 words which are beginning with letter O, let's focus our attention towards the next section of the dictionary. After O, we are going to have words beginning with letter R. How many would they be? Let's find out. Words beginning with R. Again, fix the first letter as R, left with 5 distinct places and 5 distinct letters. They can be filled in here in 5 factorial ways, which is 120, which eventually means that first 120 words are beginning with letter A, next 120 words are beginning with letter O, and next 120 words are beginning with letter R. So, 240 to 360, that means 241 to 360 basically, I will have words made up with all the letters of the word Saurav beginning with R. Saurav is not lying in this section as well. That means rank of Saurav is definitely now beyond 360, 361 onwards. It is not from 1 to 360 for sure, right? Now is our interesting section. After 360 words have been consumed, let's see how many words fall in the section in which there are words starting with the letter S, because Saurav is going to lie in this section. So that is my interesting range. Let's find out. Words beginning with S. Again, first letter fixed as S. You have 5 distinct places, 5 distinct letters to be filled. This can be done again in 5 factorial, which is 120 ways. That means what? What is the story that is being built up in here? Can you recollect? From 1 to 120, there are words beginning with A. From 121 to 240, there are words beginning with O. From 241 to 360, there are words beginning with R. And from 361 to 480, there are words beginning with S. My Saurav is, the Saurav word is lying somewhere here from 361 to 480. That means this is my interested range. Rank of Saurav is greater than equal to 361 and less than equal to 480 for sure. What did we understand? Rank of Saurav is greater than equal to 361 and less than equal to 480. Still, we have been successful in confining ourselves to a specific range, but still we have not reached that perfect number which is standing to be defining the position of the word Saurav in my dictionary. So let's move ahead and take advantage that these words are actually arranged in a dictionary order, right? Now, as I was telling you, first comes A, then O, then R, then S, then U, then V. I am now in the section of words beginning with S, that is 360 to 480 range. Now, in this section of words beginning with the letter S, I want to search the word Saurav. So, for that I want SO. But directly SO is not going to come when I am going to begin my section of words beginning with S. It is in the dictionary order. So first of all, SA, words beginning with SA are going to come. So S is fixed as first letter, A is fixed as second letter. How many words are there? With S as the first and A as the second, you are left with 4 distinct letters, 4 distinct places, so 4 factorial ways. That is 24 words are there in the section of words beginning with S with second letter A, and definitely Saurav is not lying in this section. So from 360 to 384, I have words beginning with SA. Saurav's rank is not from 360 to 384. It is 385 onwards. See, we are confining this range more and more. After SA, after words beginning with S with second letter A are exhausted, we are going to have words beginning with S and second letter O. right? This is 1, 2, 3, 4, 5 and 6 in the ordering. So S is fixed as the first letter, O as the second. I am boxing it because I want O, I am searching for the word Saurav. Again, 4 distinct letters left. Which are they? R, A, S, R, A, U and V. R, A, U and V can be arranged in these 4 places in again 4 factorial ways, which is again 24. So what you get is that from 385 to 408 you have words beginning with SO, and definitely Saurav is lying somewhere in this range. So till here what have we accomplished? That rank of Saurav, for sure, rank of Saurav is greater than equal to 385 and less than equal to 408. See, we have made this range even smaller. We're just coming closer and closer to the exact position of Saurav in the dictionary. Step by step, we are just proceeding logically just on the basis of words being placed in dictionary order. Now, we know that somewhere here Saurav is lying. So, my interested range is what? From 384 onwards. Now, I know that first letter is fixed as S, second letter is fixed as O. In this range of 384 to 408, there will be words beginning with S and second letter being O. Third letter, I want U. But directly SOU is not going to come. We are in a dictionary. SOA is going to come first. So, how many words will be there which are going to begin like this? 3 factorial, 3 places, 3 distinct letters left, which is 6. That means from 384 to 390, I will have words beginning with SOA. Saurav is not lying here. Once these are exhausted, I will have next as, now after A technically O comes, but O has been already consumed and we are not allowing repetition of letters because I want to consume all the letters of the word Saurav and still make a 6-letter word only. So after A, R is going to come. How many words can be made which begin with SOR? Again 3 factorial. So from 390 to 396 I have SOR. Words beginning with SOR, Saurav is not lying in here. This is not our interested range. Now, after these words are exhausted, I will have after R, S is already consumed, U coming. And U is my interested letter. So here, again 3 factorial such words. So from 396 to 402, what is going to happen is, words beginning with SOU are going to come, and here somewhere Saurav is going to lie. This is my very much interested range. Clear? That means now we have concluded that rank of Saurav is greater than equal to 397 and less than equal to 402. Again confined, made the range even smaller. Let's proceed ahead. Till SOU we have achieved success. RAV is what we want right now. Okay. Now after we have reached to this small range which is from 396 to 402 SOU, words beginning with SOU are lying. Now SOU has been fixed as the first 3 letters. After it, what all can come? First of all, in the dictionary order. After SOU, first of all, A is going to come. I want R, but directly R is not going to come. We are in a dictionary. So A is going to come. How many words are there which are going to begin with SOUA? 2 factorial. Because 2 places left out with 2 distinct letters. That means from 396 to 398, I will have words beginning with SOUA. Once these are exhausted, I will have words beginning with SOU. After A technically O comes, but O has been consumed. SOUR. And there will again be 2 such words which are going to begin with SOUR. From 398 to 400, I will have words beginning with SOUR. This is my interested range. 2 words are there which are beginning with SOUR. Left out 2 letters are A and V. Obviously, 399th word will be beginning with SOUR and 400th word will be beginning with SOUR. 399th word will be what? Obviously A and V are left to be arranged. A comes first, V comes later. We are in a dictionary. SOUR is already fixed as first four letters. AV, VA. 399th word would be Saurav, 400th word would be SOURVA. Obviously words need not always make any meaning, but one thing is for sure that Saurav has rank as 399. That's how logically you conclude the very argument about finding the rank of a given word in a dictionary. Now what happens is, as I was telling you, this topic is very much favorite of the JEE team. If you apply this pretty long process to find the rank, obviously it is going to give you the correct answer, but it would be very, very time consuming and tedious. And in our JEE exam, we cannot afford to even waste a single sec. So there is a small shortcut which pops up to help you out get the rank very quickly. What is that? What you do is, you write this word whose rank you wish to find. Now what you do is, you mark the orders of each and every letter which is used in the making of this word in the alphabetical form. So the very first letter is A, so A has order 1, then O has order 2, R has order 3, S has order 4, U has order 5, V has order 6. What is the next step? What you see is that after S or after order of S, how many orders are less than 4? Corresponding to S, after S, how many orders are less than 4? You can see less than 4 is 2, less than 4 is 3, less than 4 is 1. So there are 3 orders less than 4, right here 3. Come to the next letter O. How many orders are less than 2? Only 1 order. How many orders are less than 5? 3 and 1. How many orders are less than 3? Only 1. How many orders after 1 are less than 1? None. How many orders after 6 are less than 6? There is no order after 6, so 0. What did I say? How many orders are less than 4 after 4? 2 is less than 4, 3 is less than 4, 1 is less than 4, so there are 3 orders less than 4. After 2, there is only 1 order less than 2. After 5, there are 2 orders less than 5. After 3, there is 1 order less than 3. After 1, there is no order less than 1, and after 6, there is no order less than 6. Once you have written this, from back to front, start writing 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial and 5 factorial. Obviously, if there would have been more letters here, I would have continued this till 6 factorial, 7 factorial and so on. I have exhausted this here because I am terminated with the letters of the word Saurav. The drill is you need to multiply these terms. Once you compute the answers of these, you add these values. What you get, let's find out. This is 3 into 5 factorial. 5 factorial is 120. 120 into 3 gives you 360. 4 factorial is 24. 24 into 1 gives you 24. 3 factorial is 6. 6 into 2 gives you 12. 2 factorial is 2. 2 into 1 gives you 2. 0 and 0. What you get is 12 plus 2 gives you 14. 14 plus 24 gives you 38. 38 plus 360 gives you 398. What you do is, this number that you have obtained, you add 1 to it. What you obtain is the rank, isn't it? 399th word was Saurav. 399 was the rank of Saurav. Here also by shortcut method you are getting 399. Got it? Now we are going to look at the questions which were posed in JEE Advanced and JEE Main and how through shortcut method we can very quickly compute the ranks of the given word in the questions. The first question says that, asked in JEE Advanced 2007, the letters of the word Cochin are permuted and all the permutations are arranged in an alphabetical order as in an English dictionary. The number of words that appear before the word Cochin are how many? Let's see. C-O, C-H-I and an N. There is a small difference in here. Here there is C letter which is being repeated. When I was talking about the word Saurav, all the 6 letters were distinct. Here the shortcut alters a bit. What is that alteration? Let's try to study. First of all, mark the orders above each letter. In the alphabetical order, what is the order? First of all, first letter would be C. Both the C's are going to get 1 only as the order. Then it will be an H. Then it will be I. Then it will be N. And then it will be O. Okay? This is how I have marked the orders above every letter of the word Cochin. Now, what I do is the same thing but a slight alteration. How many orders are after 1 and less than 1? None of the orders are after 1 and less than 1. How many orders are after 5 and less than 5? 1, 2, 3, 4. There are 4 orders after 5 and less than 5. Let me write it with white so that it is distinct. How many orders after 1 are less than 1? 0. How many orders after 2 are less than 2? 0. How many orders after 3 are less than 3? 0. And here also 0. Now in the case of Saurav, what we did was that from backward direction to front, we started writing 0 factorial, 1 factorial, 2 factorial and so on. Here something more we are going to do, and then we are going to start the process of writing 0 factorial, 1 factorial and so on. What is that thing that we are going to do? You have to divide this number by something. What is that something? Now, if this is the 0 which is corresponding to the letter C of the word Cochin, right? Including C, how many times each letter is coming, including C and after C? So from C and after C, how many times each letter is coming? C is coming twice, O is coming once, H once, I once, N once. So you write 1 factorial corresponding to each letter which is coming once and 2 factorial corresponding to each letter which is coming twice, and you multiply them. So you are going to write 1 factorial, 1 factorial, 1 factorial, 1 factorial corresponding to O, H, I, N, and a 2 factorial corresponding to C. 1 factorial is 1 only, so you are going to get just 2 factorial. From O you have to see the letters are coming how many times, including O. You can see each letter from O and after O is coming exactly once, so this would just be 1 factorial, which is 1 only. From here, what is the drill? Including C and after C, how many times each letter is coming? It is coming only once. Including H, after H, how many times each letter is coming? H is coming once, I is coming once, N is coming once. So 1 into 1 into 1, which is 1 only. Then here also 1, here also 1. Now you write 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial and 5 factorial. Okay, same thing. Multiply, 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 multiply. When you have obtained their answers, what you do is, you add them. What is it that you get? 5 factorial is 120. 120 into 0 upon 2, which is 0, that is 0. Plus 4 factorial is 24. 24 into 4 upon 1. What is this? 24 into 4 is 96. Right? Now you have 3 factorial is 6, 6 into 0 is 0. Then you have 2 factorial into 0, which is 0. 1 factorial into 0, which is 0. And again 0 factorial into 0, which is again 0. So you are getting 96. Rank of Cochin is 96 plus 1, that is 97. Always you have to add a 1 at the end, please remember that. Okay, 97th word in the dictionary of all the words made with all the letters of the word Cochin is Cochin itself. So before Cochin, how many words are lying? 96 words, and therefore your answer is option number C, which is 96. That's how very easily through shortcut you can get the answer. Moving to the next question, we have a JEE Main 2016 post question. Again, talking about rank of a word in a dictionary, it says if all the words with or without meaning, that's not something of relevance for us, any word is going to be taken into account, having 5 letters, formed using the letters of the word small and arranged as in a dictionary, then the position of the word small is what? Let's see. Again, small is a word which consists of repetition of letters. So how are we going to address this word small and find its very ranking depending upon the shortcut used for repetitive letters in a word? You have S, M, A, L, L. Mark the orders. A would be the first letter, then L would be the second, M third, S fourth. What you need to do? After 4, how many orders are less than 4? 3, 1, 2, 2. 4 orders are less than 4. After 3, how many orders are less than 3? 1, 2, 2. 3 orders are less than 3. After 1, how many orders are less than 1? None of the order is less than 1. After 2, how many orders are less than 2? None of the order is less than 2. It is equal to 2, not less than 2. And after this 2, how many orders are less than 2? There is absolutely no order, so again a 0. Because there is repetition, you are going to divide this. How many times each letter is coming from S to the right of S? S is coming once, M once, A once, L twice. So 1 factorial into 1 factorial into 1 factorial into 2 factorial, which is nothing but 2 factorial. From M to the right of M, how many times each letter is coming? 1 factorial and 2 factorial. From here you see A is coming once, L is coming twice, so again 2 factorial. Here L is coming how many times? Twice, because including L and after L, L is coming 2 times, so 2 factorial. And here it will be just 1 factorial or 1. Now again write the same thing, 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, that's it. Multiply these and obtain the answers of these expressions. Once you have got these answers, add the values. What do you get? Let's see. 4 upon 2 factorial is 2. 2 into 24 is 48. Right? Then you have 3 upon 2 into 6. So 3 upon 2 into 6 gives you 9. Then you have 2 into 0 is 0, 1 into 0 is 0, 0 into 0 is 0. This gives you 57. But 57 is not the rank of the word small. Rank is 57 plus 1, which is 58th. Small word in the dictionary of all the words made up with all the letters of the word small is sitting at 58th position in the dictionary. Do you get it? That is how you compute the rank of a word in a dictionary. You have understood the logic to get the rank through the long method, which is a completely logical approach. On the contrary to it, you have got the shortcut methods as well. Let's just conclude this section by understanding the drill of finding the rank over another random word. Suppose I am interested in finding the rank of the word Karan. In here, if you can see, again I am allowing repetition. Why? Because A is being repeated twice. So what is the drill? This is K, this is A, this is R, this is A, and this is N. Just mark the orders above every letter. A is the first. After this you have K, then N, and then R. Right? After A comes K in the alphabetical order, and then N, and then R. Okay. Now, again apply the drill. After 2, how many orders are less than 2? 1 and 2. After 1, how many orders are less than 1? None. After 4, how many orders are less than 4? 2. After 1, how many orders are less than 1? None. After 3, how many orders are less than 3? None. Because there is repetition, again I am going to divide by something. From K, each letter is coming how many times to the right of K, including K, okay? K is coming once, A is coming twice, R is coming once, N is coming once, so you get 1 factorial into 2 factorial into 1 factorial into 1 factorial, which is nothing but 2 factorial. Then, from A to the right of A, how many times each letter is coming? A is coming twice, rest 2 are coming just once, so again 2 factorial. Then to the right of A, to the right of R, including R, how many times each letter is coming? Once, once, once. So therefore 1 factorial, which is 1 only. Here also 1 and here also 1. Clear? Now begin writing 0 factorial, 1 factorial, 2 factorial, 3 factorial and 4 factorial. Multiply and obtain the answers of these expressions. Add them. What do you get? You have 2 upon 2, which is 1. 1 into 24 gives you 24. Then this is 6 into 0, which is 0. Then this is 2 into 2, which is 4. Then this is 1 into 0, which is 0, 0 into 0, which is 0. This is 1 into 0, which is again 0. This gives you 28. But 28 is not the rank. Rank of the word Karan is 28 plus 1, that is 29. And therefore, that's where we conclude our session. All the Sauravs out there, the rank of your word, the rank of your name is 399. And all the Karans out there, the rank of your name is 29. That's it from my side, guys. Do calculate the ranks of your names and let me know. Thank you. I hope you had a good time. That's it from my side. Thank you.